In this video, we're going to look at volumes of prisms. Volume is defined as the amount of space a 3D shape contains. You should know the volume of these two shapes anyway to begin with. So a cube is length. Now normally we'd talk about length times breadth times height, but because the length, the breadth and the height are the same in a cube, then we can just say it's length times length times length, which is just length cubed. And for cuboid, then we've got our length times breadth times height. And these are both examples of prism. A prism is a 3D shape which is a constant cross section. So if we were to cut the cube along the horizontal plane, then every time we take a slice they will look exactly the same, and that would be the same for any plane that we cut the cube on. So we could do it along the vertical plane or along the diagonal plane. And similarly with the cuboid, so we could take very thin slices off the top and it would always give the same rectangle. So when the cross sections or the faces are all congruent, the shape and size, then we have a prism. And in general then, the volume is the area or the cross-sectional area times by the length. So in this triangular prism, we'd work out the area of A, so a half times base times the height, and then multiply it by the length. And in these two irregular shapes, we try and find the cross section, so this would be this compound shape, find its area and then multiply by the length of the prism. And similarly, we'd have to use some form of technique to work out this area of the face and then multiply it by the length. So example 25, find the volume of a prism with the cross-sectional area of 68 and a length of 110. So what we have is volume is the area times length. Now we'll notice that we've got a length of 110 and an area of 68. Now it's very difficult to change the 68 square meters into square centimeters, so it's much easier to change the units of length. So 110 centimeters, if we divide by 100, that's going to be 1.1 meters. So the area is going to be 68 times 1.1, which is 74.8 square meters. Example 26, find the length of a prism with a volume of 1,500 and cross-sectional area of 20. So volume is area times length. All the units are in centimeters, or to do with centimeters anyway, so we don't need to change anything. So we've got 1,500 is 20 times by the length. So what we're going to do is divide by 20 and we get 75 is equal to the length. So this prism is 75 centimeters long. If we're asked for surface area of any 3D object, then that's the total area of its outer faces. So if we have a cube or a cuboid has 6 faces, so it would have the one on the front and one on the back. It would have the bottom and the top, and then it has the 2 sides. If we had a triangular prism, then what we have, it would have the front face and the back face, and then it would have the bottom one, the side one, and the diagonal one. So it would have 5 faces, and if we worked out the area of each of the 5 shapes, or 5 faces on the triangular prism, or all 6 on a cube or cuboid, that would give us the total surface area. So example 27, find the volume and surface area of this prism. So volume is area times length, and the area is a triangle, so it's a half times the base times the height multiplied by 10. Half of 3 times 4 is 6 multiplied by 10, so that's 60 cubic centimeters. Then we need to work out the area of the faces. So if we go for the front and the back, they're going to be the same. The area is a half times 3 times 4, which is 6. So the front has an area of 6, as does the back. Then if we consider the bottom rectangle, so the base of the shape, its area is a rectangle, so that's base times length times breadth, and it's 3 centimeters wide by 10 centimeters long, so that's an area of 30. The back wall is going to be another rectangle, so it's base times length again. It's 10 centimeters long and 4 centimeters tall, so that's 40. Then we need to think about the slope, the diagonal length. This one here. So we know it's 10 centimeters wide, but we need to work out the length of it. Now what we have is that's the diagonal of the right angle triangle, so we could use Pythagoras theorem, a, b and c. We could do a squared plus b squared equals c squared, so we have 3 squared plus 4 squared equals c squared. That's 25 is c squared, so 5 then is the diagonal. So the area is going to be 5 times 10, which is 50. So to get our total surface area, it's going to be 50 plus 40 plus 30 plus 6 and plus 6, because the front and the back triangles were both 6. And that gives us a total of 132 squared centimeters. A cylinder is a prism which has a circular cross section. So if we take thin slices along the height, then we'll always get a circle as a cross section. So we know the volume of a prism is area times height, or area times length, and the area of this cross section is a circle, which is pi times r squared. So then the volume of a cylinder is pi r squared h. If we wanted to work out the curved surface area of the cylinder, so that's the full area all the way around, what we could do is, if we were to think about it in terms of a tin of beans or something like that, if we were to unwrap its wrapper, so if we were to make a cut right the full way along it and unwrap it, we would have this rectangle formed here. And what it would have is that it would be h tall, and then the width of the rectangle is actually the circumference of the circle, so that would either be pi d or 2 pi r. If a cylinder is closed, we consider it to have a circle at both ends. If it's open, then either one or both of the end circles would not be there. It doesn't change the volume, but it does alter the surface area. So the surface area of the curved surface area then of a cylinder is 2 pi rh, coming from the area of this rectangle. So example 28, find the volume of the cylinder below. So the volume is pi times r squared times h. What we can see is the width of the cylinder is 20 centimeters, which means the radius is going to be half of that, and that's 10 centimeters. The height of the cylinder is 0.3 meters, so we need to make sure that everything's in the same units, so this is going to be 30 centimeters. So the volume is going to be pi times 10 squared times 30, so that's pi times 100 times 30, or pi times 3000, and that is 9,424.8 cubic centimeters. Example 29. A cylinder has a base radius of 18 and a height of 64 and is open at one end. Okay, so what we've got is our cylinder. And it has this base length, but the top is empty. So it's open at the top only. So the volume isn't affected by that. So volume is pi times r squared times h, which is pi times 18 squared times 64. So pi times 324 times 64, which is 65,144.1 cubic centimeters. Part B for the surface area. So the curved surface area is 2 pi RH, which is 2 times pi times 18 times 64, which is 7,238.23 squared centimetres. And that's the curved part. We then need to work out the area of the base, which is a circle, so that's going to be pi times r squared, which is pi times 18 squared, or pi times 324, which is 1017.88. So then the total area, or the total surface area, is going to be those two added together, which gives us 8,256.1 squared centimetre.